Okay, hi everyone. So in this video, we're going to take a little introduction into logic, which is the second chapter of the book. So we'll take a look at the first couple sections in chapter 2. And so logic is a systematic way of thinking that's going to allow us to parse the meaning of sentences and to deduce new information from old information. And so we use logic informally all of the time outside of mathematics. Certainly logic is a very central part of proving theorems in mathematics. And so in logic, kind of the key ingredient here are statements. And so logic is a very binary thing in that statements are things that are read that we can determine whether or not they are true or false. So statements are things that either have to be true or false, but it cannot be both true or false, or it can't be neither true nor false. So let's take a look at a couple of sentences and see how we can identify whether or not sentences are statements, logical statements. Okay, so let's take a look at these 4 sentences. So number 1, the the sentence P here is saying the Earth is the center of our solar system. And so now the question that we need to consider is this a sentence which has to be either true or false, or is it possible that this sentence is both true and false, or neither true nor false? So the Earth is the center of our solar system. Either it is or it isn't. So this would definitely be a statement here because this is a sentence which has to be either true or false. And this debate has long been decided that, in fact, the Earth is not the center of our solar system. So this statement is false logically. And because we can determine it is false, that makes this a statement. Sentence 2 here says, please wash the dishes. This is a command. It's neither right nor wrong. This is neither true nor false. So this is not a statement in the logic sense. It's just a sentence that's commanding somebody to do something. So when we have a sentence which is a command, it's neither true nor false. Therefore, it is not a statement. Sentence number 3 says, the integer x is an even number. And so this statement here is sometimes true and it is sometimes false. It depends on what the value of x is, right? So if x was 3, that would be a false statement. If x is equal to 4, that would be a true statement. So in this case, in 3, this is not a statement since we can't determine whether it's true or false. It depends. And so the truth or falseness of this statement depends on the value of x. And when we have that sort of behavior, that whether or not it's true depends on the value of a variable, we call this an open sentence. Okay, and so depending on the value of x, that sentence can be true and that sentence can be false. In the last sentence here, if x is an integer, then 2x is an even number. Here, this is certainly a true statement, right? So no matter what integer we have, if we multiply it by 2, that means it is divisible by 2. So it would be an even number. And so since this is true, and we can determine that it's always true, then this is indeed a statement. So 4 is a statement, and 1 was a statement, and 2 was a command, so that was not a statement. And 3, whether that's true or false, depended on the value of x. So that is not a statement, and we call situations like that, again, an open sentence. Okay, so let's move on and now think about what happens when we start to combine some of these statements.